Hi guys, I'm Jivitan Krishnan and I'll be presenting my final year project titled Customizable Surveillance System using IoT technology. This project was developed under the supervision of Dr. Mamanade Abdul Wahab. This is Adam who wants to install surveillance cameras for 3 different locations with unique requirements besides capturing the surveillance footage. Some of the unique requirements are such as monitoring the environmental temperature, humidity, water level, soil moisture, and many more. However, Adam is not able to find a single surveillance system which serves all of his requirements. There are three main reasons for this. Firstly, the modern surveillance system serves only for a single purpose, which does not offer customization. Secondly, most of the surveillance systems which are built on top of IoT technology are highly vulnerable to cyber attacks, and this can be further supported by the recent research and also security reports on the IoT devices. And thirdly, the lack of user privacy, which makes CCTV or surveillance system a big question mark for the users, where some of the security incidents such as Workada 150,000 security camera which was hacked, which leaks the organization surveillance footages. So the proposed solution is a customizable surveillance system which is also secure, which allows users to customize their surveillance experience, provide dashboard to monitor and manage the system, receive immediate incident alert notifications, and also have advanced security measures to withstand cyber attacks and protect users' privacy. There are three main components in this system, which is the hardware, intermediary services, and the React web application. We are using a Raspberry Pi 4B as our microcontroller unit, which are connected to several components such as the cameras, magnetic door sensors, and user can also choose to customize their surveillance unit by having extra sensors. And all these components are connected through the IoT gateway. In order for the Raspberry Pi to communicate with external components, there are several communication protocols that is configured, such as RTMP protocol to perform the live streaming, image ZMQ to communicate with the image processing server, SSH terminal to communicate with the SSH server, and lastly the publish subscribe model to send the sensor data to the Firebase cloud. So these are all the servers which are all running on Node.js, and there are two main services, which is the Firebase cloud database and storage, and also Firebase cloud messaging for the alert notification. On the dashboard side, only two main communication is configured, which is the SSH tunnel to perform an SSH connection between the web server and the hardware device. And second is the HTTPS, is to communicate with all the other relying servers. There are four main modules in this system. IoT hardware involves the hardware configuration and also the configured IoT communication. The IoT security module involves security measures that is implemented to withstand cyber attacks, such as passwordless authentication, which uses a public key cryptography algorithm, streaming authorization, which provides user privacy when streaming to the streaming server, tampering detection, which have two levels of tampering, such as the hardware level tampering detection and the service level tampering detection, and lastly the communication encryption, which encrypts the SSH credential with AES-256 algorithm together with a Diffie-Hellman key exchange mechanism to securely exchange the keys. The image processing module allows the server to perform image processing services such as motion detection and tampering detection and alert the users. For the surveillance dashboard module, there are four main sub-modules, which is the surveillance monitoring, which allow user to monitor the live surveillance footage or monitor the previously recorded footage or view the reported incident all from the dashboard. And secondly, the device management sub-module allow the users to control and access the surveillance unit. And the users are also allowed to customize their surveillance unit in terms of how they want to monitor the environment. For the event-based alert sub-module, users are allowed to manage the alerts and configure the email notification services. And lastly, for the visualization of surveillance information, users are allowed to visualize the surveillance data that is collected to get insights from the data. So these are the technology that is deployed in this overall system, such as the Raspberry Pi 4B, Node.js, RTMP live streaming, web authentication standard, OpenCV, and Firebase. There are several impact and benefits of this system, such as users able to customize their surveillance unit for different use cases, while also ensuring the system is secure from cyber attack and have strong privacy encryption, which allows a customizable surveillance system that can be used for an extended period of time and reduce the electronic waste. Secondly, user can also have a centralized control over the surveillance unit through the system's dashboard. So as for the future work, we plan to add on more image processing features such as object detection and explore port forwarding for remote execution of surveillance connection and controls. This is the dashboard of the surveillance system. Firstly, before I begin the demonstration, I would like to highlight that this web application is a progressive web application, which means we can download this and install as an isolated application in our device. So in this page, users are allowed to register a new account or sign into an existing account by clicking this button. Here, user will need to click on create new account and enter the username. So for the first time, the authentication server will request to set up the security key, and we can store the security key using a physical security key, or you can use our smartphone. And then a notification will be received to verify the request. So you will need to turn on the Bluetooth. And once the devices are connected, we will need to enter the biometric or device PIN to perform the authentication. So once the registration authentication is successful, you can choose the avatar and you can enter the optional information used for account recording purpose. So once the registration is successful, we will be redirected to the dashboard with a username Pixel6. Okay, so to sign in, we will need to click on this button, passwordless sign in, and choose on our created account, which is Pixel6. So we need to use the same device that is used to register an account, and we will receive some notification to verify our identity. And once the devices are connected, we will need to give our biometric or device PIN to perform the authentication. So once authentication is successful, we will be redirected to the home page. So here we can see that we are already signed in as user Pixel6, and currently all the sections are empty. So let's create a few surveillance unit. So to create surveillance unit, we just need to click on this button and fill in the required information. The stream name refers to the surveillance unit name, and the recipient email refers to the email that will be used to send the alert notifications. So here I have already created 3 different surveillance unit or streams. For each of these stream that is created, there will be a default triggers added to the streams. So for each of these newly created streams, there will be default 3 triggers, which is the AI motion, AI tempering, and also hardware tempering. The AI motion and AI tempering will perform image processing on the real-time footage to detect if there's any motion or tempering are being detected, whereas the hardware tempering will perform tempering detection at the hardware level by using the magnetic torque sensor. So to customize the streams or surveillance unit, we can simply add on triggers, custom triggers to monitor the environment. So for example, I would like to monitor the motion in the room. So I need to enter the trigger name, stream name, GPIO pin the component is connected, and the threshold value that will need to send an alert to the user. and the recipients, so you can customize who should receive the alert notification. So I also want to add custom trigger for the kitchen, which is the gas sensor. So I want the trigger to send me alert when the value is greater than 5000. And lastly, I also want to add a trigger to the form. So here we can sort the triggers according to the streams, or we can also view all the registered streams from here. So now let's start the surveillance process. So to start the surveillance process, we need to perform SSH connection to the surveillance unit. So let's try to click on this button, and we'll need to enter all these credentials to perform the SSH connection. And let's establish the connection. So once the connection is established, we will see this model where we are allowed to perform a certain action. So firstly, let me highlight the custom command execution in the terminal. So here, user are allowed to perform custom commands on the terminal to better control or better access the surveillance unit. So for example, I can view the file system of the surveillance unit. Secondly, we can also perform the live streaming by clicking on this button. So over here, I've already started the live streaming. Okay, so let me wave my hand to check the latency. So there's a latency of around 3 to 4 seconds, and the latency depends on the network connectivity, right? Okay, now I'm going to enable the image processing server. Okay, so the server has started. Okay, so as you can see over here, by default all the triggers are disabled, and you need to enable in order to receive notification from this trigger. So firstly, let's try to enable the AI tampering trigger. So we can see that last updated time have changed. So if I try to tamper the device at the service level by blocking the camera viewport, I will receive a notification saying the AI tampering is triggered, and I can better see the logs from here. For the AI motion, if I try to enable it, the video will be recorded when there is a motion. So over here we can see that an alert is sent saying that AI motion is triggered. So try to open the log. You can play the footage to see what is the motion that is detected. So we can see that the motion is detected, and hence the video is being recorded. Next, let's see the motion sensor. I've already configured a motion sensor to the surveillance unit, and now I'm going to try to enable it. So this sensor will send an alert when there is a motion detected by this sensor, and this sensor is basically a custom sensor, so we can also use other type of sensors such as humidity sensor, pH sensor, temperature sensor, and many more. So let me try to create a motion. So when I try to create a motion, and currently only the motion sensor are activated, it will send me motion sensor is triggered. So you can see the thumbnail over here as well. So next is the hardware tempering. So hardware tempering works at the physical level, where when there is a tempering detected at the hardware, especially the surveillance unit, then an alert will be sent. So let's enable this. So when I try to temper the device, I will receive a notification on the dashboard as well as the email. So these AI tempering and hardware tempering both have a cooldown time of 300 seconds, which is around 4 to 5 minutes, to prevent the spam of alerts or notification being sent to the users. Right. So next is let's try to disable this. Okay. So next I would like to end the surveillance. Okay. So in order to end the surveillance processes, we just need to SSH again. And you can just simply end the surveillance process by clicking on stop scripts. So as we can see from here, the stream have been deactivated, right? Okay, so next I would like to explain about the alerts. So alerts is a tab to view and also manage the alerts that is being reported. So from here, users can view the information of the alerts, what type of trigger, when is the alert being triggered, and can also edit the review status of the alert. For example, you can change to in progress or resolved. And you can also delete the alert as well. For the notification, the alerts will be sent through the dashboard and also the email that have been registered. So here we can see there is a hardware tempering sensor that is being triggered, and from here we can also see the image as well. So you can also see an AI motion sensor is being triggered at user pixel 6. So here we can view the footage of what are the motion that is being detected. Okay, in the archive section, user will be able to view all the previously streamed footages, such as over here. So you can simply view the footage by clicking on the discard. So here you can see the footage that was streamed a while ago. So from here, users can view the archive recording from the surveillance system. For the visualizer, I'll be using another account for a better data visualization. So in this section, we will basically see the summary of the surveillance data to provide useful insight for the users. So as we can see here, you can see the total streams that is registered, the total number of triggers, and how many active triggers, as well as the number of alerts and the number of alerts that have been not yet resolved. In the second section, we can see the triggers by priority, where 16 are labeled as high, 1 is labeled as medium, and none is low. And we can also see the alerts by priority, and lastly alert by status. So from here we can identify how is the progress of the alert notifications. So you can see that 33 are still being pending, 1 in progress, and 13 have been resolved. In the next section, we'll be able to see the reported alerts according to the stream. So this is basically the timeline of to identify the trend of the alerts in each of the streams. So there are currently 2 streams that have reported alerts. So you can see over here, there have been a hike in the stream called Race2 from April 5 until May 26, and there was a decline in alerts from May 26 up until July. Whereas for the Kun stream, there is a hike from April 3 until April 4, and the alert significantly drops from April 4 until May 21, and slightly increased from June 1 to June 3, from June 1 to July 3. So from here we can easily identify what is the trend and do some prediction on how are the alerts or what are the precautions that needs to be taken. Next is the stream statistic. So from here we can see the statistic of the stream according to the performance of the trigger. So from here we can see the AI motion have the most number of alerts that is being sent, followed by the AI tempering, and followed by the hardware tempering, and so on. So you can also view this according to the streams as well. So we can see for Tekun, there are the main contributing trigger is the AI motion, followed by the AI tempering, followed by hardware tempering. Lastly, for the alert statistic, you can see the statistic of the alert in two aspects. One is the priority of the alert, which is high, medium, low, and secondly is the status of the alert, which is pending, in progress, and resolved. So for example, let's take Tekun. So we can see for Tekun there are 29 alerts that is labeled as high. There are none of it labeled as low or medium, and one is medium. And there are 12 alerts that have been resolved, one in progress, and 17 are still pending. So from here we can simply understand the stats of alerts according to the streams. So that is all for my demonstration. Thank you.